Okay, good morning, everyone. So, how is the problem set going so far? I hope you guys already started kasi yung deadline na nun ay, kailan yung deadline ng problem set natin? Tomorrow, right? Right before midnight tomorrow or 5 p.m. Alam ko kung ano yung tama. Pero I can extend it until midnight kung ang deadline natin ay 5 p.m. Right? So, any problems with it so far? Any initial reactions? Or ayaw nyo nang pag-usapan? Gusto nyo muna nang kalimutan for today? Talaga ayaw nyo mag-react? So hopefully you're having fun working on it. Mahirap? Talaga? Okay, baka...
Yung last
Okay,
question
so
po.
kung napahirap, ano yung last question? So 1.3 nga ba?
Yes po, sir. Pero okay naman po.
Yung alpha...
Challenging lang.
Okay. Okay, kailangan nyo lang pag-isipan ng konti. But I hope 1 hour is good for at least all the other problems except possibly dun sa sinabi nga ni Gad na problem 3 sa 1.3. So hopefully everything is fine. And again, I won't discourage you guys to, if you're really stuck, you tried the problem number 3 on your own or among yourselves, and then you find it very difficult. I won't and I cannot prohibit you from checking out the internet for to draw some inspiration kung ano yung mga existing proofs. So pwede kayong tumingin just to get an inspiration. You might see a full proof in the internet or in other textbooks kasi sige, bibigay ko sa inyo yung keywords kung medyo mahirap. Pythagorean triples. So, di ba, remember, nandun ay alpha squared plus beta squared equals gamma squared, right? So, ano lang siya, parang Pythagorean triples, mga integers na nakakasatisfy ng Pythagorean theorem, right? Like 3, 4, 5, what else? 5, 12, 13. So, these are examples of values for alpha, beta, and gamma respectively. Tapos gusto kong ipakita dun sa theorem na kapag ka meron kang Pythagorean triple, alpha, beta, and gamma, sure tayo na si alpha, isa kay alpha at saka kay beta ay, ano nga, odd or even? Kalimutan ko yung theorem. Dapat at least isa sa kanila ay...
Even po.
Even. Alright, thank you. Yeah, dapat isa sa kanila, at least isa kay alpha at saka kay beta ay even. So it doesn't matter what the value of gamma is, as long as gamma remains to be an integer, then we are sure that in any Pythagorean triple, there is at least one that is even. So imposible na magkaroon ka ng Pythagorean triple na si alpha at saka si beta ay parehas even. Kung mahirap itong i-attack directly, pwede kayo mag-proof by contradiction or proof by contraposition. Try nyo yun. Kung medyo nahirapan pa rin talaga, tapos medyo hindi nyo na alam gagawin, malapit na ang deadline, draw some inspiration from the internet, okay? Parang training na rin to sa inyo para paano mag-research. But make sure that what you write, that you understand what you write on your paper. So pag sinubmit niyo yun, ang assumption ko, naintindihan nyo siya. Alright? So, hindi naman original yung mga pinapaprove ko. So you can take a look at the internet kasi problem set, take advantage of technology that you can use, right? So pwede nyo tingnan ano yung ginamit sa proof. Tapos intindihin nyo ano yung ginawa sa bawat linya ng proof. Tapos i-try nyo siyang i-rewrite on your own. Okay? So yeah, yun yung hint doon. Okay? But I hope the other problems are easy or are manageable. Meron lang pala ako ditong typo sa 1.3.2. No funny function. Dapat walang S. Kasi easy yung ginamit ko. No funny function is continuous. Alright. So sa 1.3.2. Nag-iisip ako ng ipapangalan dun sa function. Gagawin ko sana differentiable o kaya continuous. Kaya lang hindi magiging maganda yung basa mathematically. So ginawa ko na lang funny function. But if you're wondering, walang definition ng funny function. So nilagay ko lang siya dyan. Parang sort of a placeholder. So tinawag ko lang siyang funny function for no mathematical reason at all. Any other problems or concerns? Medyo narcissistic yung example of one, ay problem one. Wala akong maisip na variable, so yeah. Okay, any other questions or complaints about the problem set? Do you think, guys, you can manage to submit it tomorrow? Oh, yes, Daniel.
For 1.3.1b, should the argue I want yeah, yeah. Should the arguments be sound, sir? Or it's okay not?
Not necessarily. Basta magbigay lang kayo. Ang gusto ko lang mangyari ay magbigay kayo ng value kay n of x or ng statement n about x, statement j about x, statement a about x, and statement e about x. Tapos gusto kong matranslate nyo into English. Ito, yung argument. It doesn't matter if it would be a sound argument. So, bahala na kayo. Basta valid yung argument. Basta kasi, sabagay, na-prove nyo na sa A na kahit ano man yung statements N, J, A, and E, lagi siyang valid kung ganito lagi yung form. So, bigay lang kayo ng meaning dun sa bawat isang prepositions involved. Tapos, ita-translate nyo into words kasama yung quantifiers, and that's fine. It doesn't matter if it's sound or not. Okay? O, dapat pala sinabi ko yung sound, no? Binigyan mo ako, Daniel, ng idea. Sayang, hindi ko naisip yun kagad. Para matest ko kung naintindihan niyo yung konsepto ng pagiging sound, no? But luckily, hindi ko na na-specify na dapat sound yung arguments. So kahit kahit hindi sound yung arguments. Okay? All right, any other questions? Reklamos, ano pa ba? Wala naman? Okay, so mangyayari dito ay I will grade problem set 1.1 and 1.2. So kung may reklamo kayo sa pagkakagrade nun, sa akin kayo mag-i-email or mag-chat. Dito sa 1.3, yung lab instructors niyo mag-check. So sa kanila kayo magreklamo. So hindi ko sila papakialaman. Probably I'll just give them an answer key. So para makapag-check sila. And probably a generic rubric, pero bibigyan ko sila ng liberty kung paano mag-distribute ng points sa 1.3. So if you have some questions about how 1.3 will be graded, so go to your lab instructors. The rest, 1.1 and 1.2, ako yung mag-check. So sa akin kayo magreklamo. Alright? So kung wala naman kayong reklamo na, so probably we can now move on and start module, I think this is module 6. Though we are at the 7th week of the semester, we're really one week behind. But again, that's fine. We can adjust later. So this module is concerned about the principle of mathematical induction. So ito ay isang topic na supposedly nasa bandang dulo pa. It comes after we construct the set of natural numbers. Kaya lang naisip ko na maganda na matutunan nyo na itong proof by mathematical induction because it's a very powerful proof technique and I don't want na i-cramp siya or madaliin siya towards the end of the semester. So I want to introduce it now where we have more time. So, kasi isa siyang method of proof. So swak siya dito sa section na pinag-aaralan natin. And at the same time, once we learn the principle of mathematical induction, at least on an intuitive level, we can use this proof technique in order to prove some properties about sets when we go to the second part of the course. And then, yeah, gagamitin nyo rin to sa iba't iba yung mga klase, major classes right after 101. Okay, so have you encountered the PMIE already? Siguro sa Math 20 or Math or AMAT 19 or sa Math 30 series? Narinig niyo na ba itong principle of mathematical induction? Or hindi pa? Or ayaw nyo lang sabihin para pampababa ng expectations? Okay. But yeah, that's our goal for the week. Okay, either hindi pa or hindi maalala. Okay. Medyo familiar? Okay, good. So yeah, kaya lang at this point, wala pa sa atin yung theoretical foundation kasi ang pinaka-justification or kung saan nanggaling tong principle of mathematical induction ay sa construction ng set of natural numbers. So kaya siya usually dinidefer dun sa dulo ng set theory after ma-construct natin from scratch ang set of natural numbers. So wala pa tayong axiomatic development for the set of natural numbers. So ang gagawin ko ngayon, i-discuss ko yung PMI on an intuitive level. Ano yung ibig sabihin niya or ano yung bakit siya nag-work as a formal proof. But on an intuitive level or layman's term, maintindihan natin siya yung theoretical meaning about it siguro later na after nating mo-construct yung set of natural numbers. And that's why if you're looking through the Mojo, the worktext, nandun pa talaga siya sa bandang dulo. Pero that's why I decided to slightly modify that part of the worktext into this PDF file. So it's a separate PDF file. I hope you can see, you have seen this under the modules. I think it's under module 6 or study guide for week 6. So tingnan nyo dun sa Canvas, hanapin nyo siya, individual file. Pero ang ginawa ko na lang naman, ni-rephrase ko lang yung parts ng proof na nasa worktext saka yung mga examples nito. Essentially, nothing new about it, except possibly nagdagdag din ako ng examples para mas marami tayong iso-solve for this week. Okay? So let's get going. Okay. So the principle of mathematical induction. So it's a very nice and powerful tool to help us prove theorems that hold for all natural numbers or for natural number or starting at a natural number and all numbers thereafter. So kung yung theorem nyo, claim na totoo itong statement na to for all natural numbers or for all natural numbers greater than or equal to some number k. Halimbawa, sabi niya, itong theorem na ito ay totoo for n greater than or equal to 6. Kaya n greater than or equal to 3. Then that means the PMI is a viable option to prove that particular statement. Okay? And then a little caveat here bago pala ako magpatuloy. Yung development kasi sa textbook, set of natural numbers siya ay nag-start sa 0. Okay? Though it is not a big deal if we will start our set of natural numbers to 1 or 0 kasi hindi nga nagmamatter yung first few finite terms sa set of natural numbers. Pero I think ginamit natin all throughout so far sa Math 101, ang n natin ay nag-start sa 1. Tama nga ba? Yan yung convention natin, no? Nakalimutan ko itong convention sa textbook when we started discussing. I think we defined n to be the set containing 1, 2, 3, 4, 5, and so on. Kaya lang later, babaguhin natin yon. Ang n natin, sisimulan natin kay 0 kung susundin natin yung worktext. Or pwede ko siyang simulan kay 1, pero i-edit ko lahat ng 0 dun sa part na natural number system kay worktext. So probably in this context, siguro gawin natin, paano kaya natin ito sosolusyonan? Kasi ang gusto ko ang n magsimula sa 1. Kaya ganun yung ginamit kong definition ng simula. Pero ngayon yung textbook nga pala nag-start sa 0. Nawala sa isip ko. Ngayon, kaninang umaga ko lang naalala. That's why you will see here that the theorems proved using PMI usually starts when n is equal to 0. Okay, siguro for now, let's think about n to include the number 0. Okay? So at least sa portion ng PMI at saka later sa portion natin ng set of natural numbers. So, pero sana hindi siya mag-cause ng confusion kasi in most of your courses, the set of natural numbers starts with 1. Okay? Pero for now, let's think of it as starting from 0. Okay? So, that being said, paano nag-work yung PMI? So, meron ditong steps. So, tingnan natin yung steps para kay PMI or yung formal statement of the PMI. So, it says that if we will consider a statement P about n, so it's a statement that the natural number n has the property P. Now, if P of 0 holds true, okay, so una kailangan natin ipakita na nag-hold siya kay 0. We need to show that P of 0 is true. Or, in the case when the theorem just claims the statement to be true for a starting natural number aside from 0, kailangan natin i-prove na yung statement ay totoo dun sa kauna-unahing natural number kung saan siya kine-claim to be true. Right? Kailangan meron tayong basis step. Meron tayong isang natural number kung saan siya ay totoo. Yun yung starting point natin. And then if it is also true, or if we will assume that it is true for a certain natural number m. So i-assume natin totoo siya kay P of m. Tapos if we can show that it is true for P, if we can show that it is true for m plus 1, then we can show that P of n is true for each natural number n. So ganito yung idea. So, di ba, meron tayong mga natural numbers. 1, start nga pala kay 0. Hindi ako sanay nag-start kay 0. 0, 1, 2, 3, 4, 5, 6, and so on. Okay. So, sabi sa PMI, una, pakita natin totoo yung theorem dun sa unang-unang natural number kung kanino kiniklaim yung statement to be true. Usually, mag-start ka kay 0. So, we need to show that P of 0 is true. I-check natin yan. Plug in n equals 0 to the statement, check if it is true or not. Usually, napaka-obvious ng P of 0. So medyo tricky siyang isulat paminsan-minsan, pero we'll see some examples about that. But you always start by showing that the statement is true for the smallest natural number for which the statement is claimed. So mache-check mo na yan. Okay, totoo siya dun sa unang-una. Ang tawag sa kanya ay basis step. Kasi siya yung pinakabasihan o simula ng PMI. Okay? Pangalawa, kailangan nating i-prove that if that P of M implies P of M plus 1. So i-assume natin as an assumption, or gagamitin natin as an assumption na si P of M ay totoo. Tapos from there, we want to show that the statement is also true for M plus 1. Okay? Again, dito sa pangalawa, ito yung tinatawag na induction step. I-assume natin si P of M. Ang tawag kay P of M ay hypothesis of induction. Kunwari, totoo siya kay M. Tapos from there, we want to show that if it is true for M, totoo rin siya kay M plus 1. And then sabi ng PMI, if these two guys are satisfied, then the theorem is true for all natural numbers. Bakit siya totoo nangyayari? Okay. Na-prove natin na totoo siya kay 0. Alright? Tapos, kung na-prove natin itong pangalawa, ibig sabihin kung totoo siya kay 0, so totoo siya kay m equals 0, so dapat totoo rin siya kay 0 plus 1. So that means the statement is true for n equals 1. Tapos totoo siya kay 1, so P of 1 is true. But from the induction step, that will mean that P of 1 plus 1 is also true. So, totoo siya para kay 2. Oh, totoo siya kay 2. So, kung totoo siya kay 2, by the hypothesis, by the induction step, totoo siya dapat also for 2 plus 1. Right? So, totoo siya kay 3. Tapos, by that process again, totoo siya kay 4, totoo siya kay 5, totoo siya kay 6, and so on. So, ganyan nag-work yung principle of mathematical induction, at least on an intuitive level. When we go to chapter 2, we'll go back to PMI and see justify natin siya theoretically or axiomatically based on how we constructed the set of natural numbers based on Peano's axiom. But for now, you can think of it as a long chain of arguments. Basis steps, yun lang yung specific case na i-consider natin, yung simula. So kung totoo siya sa simula, okay, meron tayong starting point. Then we will show na totoo yung induction step. Pag totoo siya kay P of M, totoo siya dun sa susunod na natural number. So it creates a chain of true statements that will encompass all natural numbers N. Kaya siya nag-work sa N kasi definitely pag may natural number ka, alam mo yung kasunod niya. Pero hindi siya mag-work sa real numbers kasi pag meron kang real number, hindi natin kayang i-explicitly sabihin kung sino yung susunod na real number doon. Okay? So ito yung peculiarity ng natural numbers that allows PMI to work. Okay? So, is that medyo convincing ba? Na-convince ba kayo dun sa justification kung bakit totoo itong PMI? Right? So, para siyang long chain of arguments. Parang pinuprove mo siya isa-isa. And then, pag pinprove mo siya sa basis, salamat dun sa induction step, hindi mo siya kailangan ipakita for P of 1, for P of 2, for P of 3, and P of 4. Kasi nagpa-follow na siya mula dun sa induction of hypothesis. Sorry. Sa induction step. Right? Okay, perhaps it might be easier to understand this if we look at a particular example and see how we can use PMI to prove certain statements. Ito yung susundin nating outline. So una, pwede niyong i-state ano si P of n para mas klaro. Okay? And then the next step is the basis step. Ano yung basis step? Sa basis step, gusto nating ipakita na si P of 0 ay totoo. Okay? Pero kung yung statement nyo naman, sabi totoo lang siya for natural starting at a natural number, say 6, 7, or 8, o sa isang specific natural number, yun yung ipapakita nyo, yung pinakamaliit na natural number for which the statement is claimed. Yun pa rin yung magko-constitute ng basis step. PMI should start somewhere. Okay? So kailangan pakita nyo siya totoo sa isang specific natural number, namely yung natural number kung kanino kiniklaim yung statement to be true. Okay, and the third, state the hypothesis of induction. Yung hypothesis of induction, siya lamang yung papalitan nyo lang si n by the variable m. So suppose nyo, kunwari, totoo yung statement kay natural number m. Okay? And then the last part is sort of the deductive step, pero tinatawag siyang induction step. Mula kay P of M, gusto nating ipakita na si P of M plus 1 ay totoo rin. Usually, or actually hindi nga lang usually, laging ginagamit yung hypothesis of induction dun sa pagpuprove na si P of M plus 1 ay totoo. Para masimulan natin yung chain, para matuloy natin yung chain. Nagsimula yung chain kay P of 0 dun sa basis step. Hypothesis of induction, kunwari totoo si P of M. Prove natin na totoo si P of M plus 1, then the chain will get going. Totoo si P of 0, then totoo si P of 1. Dahil totoo si P of 1, totoo si P of 2. Dahil totoo si P of 2, magiging totoo si P of 3, and so on. So, ganun na-create yung chain of true statements that will be true for all natural numbers. Okay? So, tandaan nyo itong 4 na steps, pero actually, pwede nyo siyang ma-reduce sa dalawa. Basis step, actually 3 pala. Basis step, state the hypothesis of induction. And then third, do the induction step or prove that P of M implies P of M plus 1. So let's look at some examples para maging mas familiar kayo sa PMI. Okay. So this is a nice formula for summing up the consecutive natural numbers. Actually, this one is, according to legends, this was proven by Carl Friedrich Gauss when he was in his elementary days. So, ang summation ng k, as k goes from 0 to n, ay n times n plus 1 all over n. Okay? So we can prove it using the principle of mathematical induction because it is claiming that it is true for all natural numbers n. Okay. O dito pala pwede kong, hold on. Napaisip ako. Mag-stick ba ako mag-stick ba ako sa n ay nag-start kay 0 o nag-start kay 1? So sabi ko nga hindi siya malaking bagay, hindi guguho yung mathematical foundation natin kung doon natin sisimulan sa set of natural numbers. Kaya lang cringy para sa akin mag-start sa n sa ang natural numbers kay 0. But anyway, sige, pangatawan na natin to. Nagsimula siya kay 0. Okay. So pag nagsasum ka raw ng 0 plus 1 plus 2 plus 3 until n, ang sum niya lang ay n times n plus 1 all over 2. Okay. And since this is claimed for all natural numbers n, then PMI can be used to prove it. Now, to illustrate the theorem, siguro para makita natin paano yung theorem. Yung theorem kapag kasi n ay 0, ito lang yung specific statements ng theorem. Kapag kasi n ay 0, ibig sabihin meron lang tayong 0 equals, so kasi yung summation dun sa kaliwa, nag-stop siya kapag kasi n ay, nag-stop siya kay n. Alright? Nagtatapos siya kay n, nagsimula kay 0, nagtatapos kay n yung summation. Now, if n is equal to 0, then isa lang yung term na nandun sa kaliwa. Kasi starting at 0, ending at 0, so 0 lang nasa kaliwa. Tapos yung nasa kanan, magiging 0 times 1 over 2. Ito yung statement P of 0. Ito yung P of 0. And then when n is equal to 1, makukuha natin yung statement P about 1, which will become 0 plus 1. Because again, the left-hand side is a summation starting from 0 hanggang kay n. So ang n natin ngayon ay 1. So ibig sabihin yung kaliwa magiging 0 plus 1. Tapos yung kanan, papalitan pa lang lahat ng n by 1. So I'll have 1 times 1 plus 1 all over 2. Okay. Now, if n is equal to 7, halimbawa, P of 7, it will be 0 plus 1 plus 2, all the way up to 7. Pero ang kiniklaim ng theorem, equal daw ito, kay 7 times 7 plus 1 all over 2. Okay? So ito yung specific statements ng theorem. And we don't care about, usually in PMI, we don't care about the larger values of n. Ang kailangan lang natin talagang i-consider ay yung basis step. Saan nagsisimula yung claim? Yung claim dito sa statement ay totoo daw to sa lahat ng natural numbers n. So sisimulan natin yung PMI natin by the basis step, taking the case that n is equal to 0. Okay? But before we proceed, is everything clear so far? Clear naman yung expansion ng theorem? Alright? Mukhang tahimik kayo ngayon, ah. Or nagagawa ba kayo ng problem set on the side? Okay, so let's start the proof. We can say proof by PMI if you want. And then let's start with the basis step. So, pwedeng hindi nyo i-bullet, pwedeng paragraph form, that's fine. Pero siguro sa simula, gawin ko siyang bullet step para mas ma-familiarize kayo, but you don't have to do it bullet type, pwedeng essay type pa rin yung sundin nyo, right? So, label ko lang yung bawat parts para makita nyo siya pag ni-review nyo siya later. Pag sanay na tayo, tanggalin na natin yung bullets, okay? So, we start with the basis step, look for the smallest natural number for which the statement is claimed. The statement is claimed when n is first claimed when n is equal to 0. So let's do P about 0. Okay, ito yung gusto natin i-prove. So we want to show that P of 0 is true. Ito yung goal natin sa basis step, right? And then remember, we are proving here an equation. So mag-start tayo dun sa isang side ng equation and so that the other side will follow, right? So note that if we start with the left side is just 0. And 0 is the same as 0 times 0 plus 1 all over 2. Because this guy is equal to 0 over 2. All right? And actually, this is the end of the basis step. Kasi hindi pa end of proof, pero end lang ng basis step. Kasi napakaklaro naman na yung left-hand side ay equal din sa right-hand side upon substitution. Tama? Okay. So that proves that the statement is true dun sa smallest natural number, which is 0. Okay? So I hope it's clear kung bakit medyo mahirap isulat kapag ka-obvious, no? Para mapapaisip ka, hindi ba ito yung bawal daw isulat, sabi ni sir, na mag-start dun sa gustong ipakita. Kaya lang ang problema, yung gusto nating ipakita ay napaka-obvious. Yung right-hand side ay ito. Pag sinimplify mo, equal siya kay 0, which is eventually the left-hand side of the statement P about 0. Okay? But nevertheless, we have proven na totoo siya kay 0. Okay? The next would be the statement of the hypothesis of induction. So for the hypothesis of induction, ipapagpalagay natin na totoo yung statement for some natural number n. So we assume that for some natural number n, the statement is true. Ibig sabihin yung 0 plus 1 plus 2 until m ay equal kay m times m plus 1 all over 2. Okay? ito yung gagamitin natin para dun sa induction step. I-assume natin na totoo yung statement for a specific natural number m or for an arbitrary natural number m. Okay? So, sulat nyo lang siya. And what we want to show is P about m is true. Right? Ito yung sinasabi ng induction step. Magsimula ka kay P of m, pakita mo na totoo rin si P of m plus 1. Right? So it usually helps to write what is the statement that you want to prove para magkaroon ka ng direction. Ano kaya yung gagawin ko dun sa dun sa HOI para mapakita si P of m plus 1. So siguro sulat yung si P of m plus 1 para makita nyo or para mag-guide kayo ano nga ba yung gusto kong mangyari in the end. So here, I want to show that 0 plus 1 plus 2 plus until m plus m plus 1. Because remember here, this is the statement to be proven. Nagtatapos siya dun sa natural number na nandun sa loob ng statement P. Ang nasa loob ng statement P, dun sa we want to show natin ay m plus 1. So dapat si n dito mapapalitan ng m plus 1. So the summation here will end at m plus 1. And the same thing will happen to the right-hand side. So sa right-hand side, lahat lamang ng n, papalitan ko ng m plus 1. So I will have m plus 1 times m plus 1 plus 1. So it's going to be m plus 2 all over 2. Ito yung gusto nating ipakita. Right? So ito yung assumption natin. And almost always gagamitin yung HOI. Actually, sa PMI, laging ginagamit yung HOI unless super obvious ng theorem. So, gagamitin yung HOI para mapakita itong statement na to. And then usually, that's why I want to put the HOI and the WTS part side by side para alam ko ano yung pinagkaiba nila. Para alam ko yung gagawin ko dito sa HOI para mapakita yung gusto natin ipakita. Right? So, lagay ko lang to ng box para hindi nakakalito. Ibig sabihin, ito yung statement na gusto natin ipakita. But again, I will compare them. Specifically, the left-hand side. How do they differ? Anyone? Ano yung pinagkaiba ng mga left-hand side sa HOI saka sa WTS? Oh yes, Mary Rose.
Sir, is it m plus 1 po?
Okay, thank you, Mary Rose. That's perfect. So tingnan yung left-hand side nung assumption at saka nung gusto nating ipakita. Nagkaiba lang sila. Ito nagtapos sa m plus 1. Yun lang talaga yung pinagkaiba nila. Pero remember, yung HOI, ina-assume na natin yan to be true, right? So ibig sabihin from here, I can say that it will directly follow that. Copyhin ko lang to. Actually, pwede ko copyhin yung buong statement kasi ina-assume ko na totoo itong buong equation na to, right? Ayun yung nasa HOI. Kunwari, totoo yung statement kay M. So, totoo itong equation na to, pwede ko siyang gamitin ngayon dun sa pagpapakita ng P of M plus 1. And Mary is right. Ang pinagkaiba lang dun sa P of M plus 1, nagtapos siya kay M plus 1. So, what I can do here is to use the addition property of equality. I can add m plus 1 to both sides of the equation. And in doing so, we'll get this. Mag-add lang ako ng m plus 1 sa magkabilang side. Okay. Tapos nakuha ko na yung left-hand side nung gusto nating ipakita. Right? The only thing that should be done here is to show that this guy is equal to this guy. All right? Para ma-establish natin yung truthfulness ni P of m plus 1. But this is just, this will just require some manipulations, right? So, pwede ko itong isulat na m times, what? M squared plus m all over 2 plus 2 times m plus 1 all over 2. So mag-algebraic manipulation lang ako rito. And then this will become m squared plus m plus 2m plus 2 all over 2. Sana tama yung pagkakasimplify ko. Kung may problema, pakisabi naman kagad. Alright. And then this will become m squared plus 3m plus 2 all over 2. And then I can factor this as what? Can factor this as m plus 1 times m plus 2 all over 2. Which, if we go back to what we want to show, is exactly the right-hand side that we wanted. Right? So therefore, kung totoo si P of M, magfa-follow na totoo si P of M plus 1. That's we have proven here. So therefore, we can end our statement by saying na by PMI, 0 plus 1 plus 2 until n ay equal lamang kay n times n plus 1 all over 2. And again, the reason is we have created the chain of two statements. Totoo siya kay 0. Tapos kapag totoo siya kay m, automatic totoo rin siya kay m plus 1. Yung na-prove natin sa induction step. So totoo siya kay 0, so ibig sabihin, totoo rin siya kay 1, totoo rin siya kay 2, totoo siya kay 3, totoo siya kay 4, totoo siya kay 5, and so on. Eventually, mako-cover natin lahat ng natural numbers, so we can say that this summation formula is true for any natural number. Okay? And that ends the proof. Does that make sense, guys? Tapos nakita nyo ba yung paggamit ng induction hypothesis para mapakita yung induction step or para ma-prove na si P of M plus 1 ay totoo? Yun yung kagandahan sa PMI kasi usually alam mo kung ano yung gagamitin mo. Dapat magamit mo yung HOI somewhere. Okay? So usually it's a nice practice, really a very good practice. Kahit hanggang ngayon ginagawa ko to. Sulat ko yung HOI, kasi sulat ko yung WTS para ma-compare ko ano yung dapat kong gawin sa HOI para makarating ako dun sa WTS. Okay? Talaga ba hindi kayo nag-react ngayon, guys? Or connection ko lang yung mahina? Tahimik niya yata ngayon.
Midterms po kasi.
Okay. Thank you, Gad. Okay. Probably one more example. Let's look at example number 2. Okay. No problem, Mary. Meet safe. Yeah, that's fine. Medyo kinakabahan na ako kasi hindi kayo nag-react. Usually, pagka nagtatanong ako, may mga pa-reactions kayo na thumbs up eh. So siguro ngayon, busy kayo talaga sa problem set, no? Okay, let's try the second example. So for all natural numbers n greater than or equal to 1, we want to prove that 2 to the n minus 1 is less than or equal to n factorial. Familiar ba kayo sa n factorial? Hindi galit yung theorem, kaya exclamation point yung ginamit. So ang ibig sabihin ng n factorial, it is the product starting from 1 until n. And it only works, at least for now, for natural numbers. Meron siyang extension kapag real numbers, pero siguro yung mga applied math sa probability theory nyo siya makikita when you talk about the gamma distribution. Pero ano lang natin siya, tingnan natin siya for natural numbers. For instance, ang 1 factorial ay product simula kay 1 hanggang kay n. So si n dito ay 1, so 1 factorial is equal to 1. 2 factorial is the product starting from 1 until 2. So it's going to be 1 times 2. So sagot niya 2. 3 factorial is the product from 1 until 3. So that's going to be 6. 4 factorial is the product from 1 until 4. So that's going to be 24. 5 factorial is what? 5 factorial is 120. And then 6 factorial is 720, and so on. All right? So, ganyan yung definition ng factorial. And by convention, ang 0 factorial ay defined to be 1. Wala magtatanong kung bakit si 0 factorial ay equal kay 1. Nagkasundo yung mga mathematician for some technical reasons na ang 0 factorial ay equal kay 1. So don't question why 0 factorial is 1. May mga technical reasons, but actually, nagkasundo lang yung mga mathematicians na tawagan siyang 1. Okay? It's a convention. Now, this is what we want to show, right? So, kung clear na yung factorial, i-attack natin yung statement by PMI. And again, we can do PMI here because the statement is being claimed for all natural numbers greater than or equal to 1. Hindi nag-start kay 0 yung claim. Though, tungkol pa rin siya sa mga natural numbers, but this time nag-start siya kay 1, which is perfectly fine. It's just that mababago lang yung basis step natin. We will show that the statement is true when n is equal to 1. Okay, so can start the proof that way. Okay, please. Let's do it by PMI. Then let's do the basis step. Okay, we want to show that, or want to at least state that P of 0 is P of 1 is true. So we can say, note that, ano ba yung mangyayari kapag ka si n ay 1? Kapag ka si n ay 1, yung left-hand side ng inequality, maging 2 to the 1 minus 1, which will become 2 to the 0. So this guy will be equal to 1, right? And then n factorial is 1 factorial. And 1 factorial, as we have seen in the illustration earlier, ay equal lamang kay 1. So basically, that's a tautology, right? 1 is less than or equal to itself. So therefore, we can say that 2 to the 1 minus 1 is equal to 2 to the 0, which is equal to 1, which is actually less than or equal to 1, which is the same as 0 as 1 factorial. Okay? So, ganito nyo lang siya. Pwede nyo siyang i-argue ng ganun. Start kayo dun sa left-hand side, compute nyo siya, tapos lagyan nyo yung less than or equal to yung simplified form nung right-hand side para masabi nyo na totoo itong nasa middle equality, yung nasa gitnang inequality. Tapos yung 1, express nyo lang as yung as the right-hand side dun sa theorem. Okay? Para mas obvious na napakita natin na yung 2 to the n minus 1 ay less than or equal kay n factorial when n is equal to 1. Okay? Medyo discartean nyo na kung paano nyo isusulat yung basis step. Pero ganito yung suggestion ko. You start with this guy. Oops. Okay? Try to plug in n equals 1. So ginawa kong ganito. Inunti-unti ko para makumbinsi yung reader. Equals siya kay 2 to the 0. Ang 2 to the 0 ay equal kay 1. Pero dun sa preliminary analysis, nakita ko na yung right-hand side ay equal kay 1. So yun na yung ilagay ko dito para convincing na si 1 ay less than or equal kay 1 kagad. Kasi ang gagawin ko, ito, i-express ko pabalik dun sa unsimplified form ng right-hand side. Para eventually masabi na yung 2 to the 1 minus 1 ay less than or equal to kay 1 factorial, which will establish the basis step. Okay? Napunta tayo sa hypothesis of induction. Ano kaya yung hypothesis of induction? Any volunteer? Paki-state yung hypothesis of induction. Yes, Mary Mitzi.
Ano po, sa substitute lang po natin yung m dun sa m. So, bale, 2 raised to m minus 1 is less than or equal to m factorial.
Okay, thank you, Mary. That's right. We will assume that for some natural number m greater than or equal to 1. So yung sa HOI, medyo maliit na technical detail, I assume nyo siya itotoo sa isang m na pasok dun sa original assumption. So I need to put here not just m is a natural number, but I will assume that it is true for a natural number m greater than or equal to 1. Kasi yun yung covered in theorem. Okay? Then tama si Mary. Ang assumption ay 2 to the m minus 1 ay less than or equal kay m factorial. Okay? And then what do we want to show? Can somebody tell me what is the simplified form nung gusto kong ipakita sa induction step? Oh, yes, Gad. Ano yung WTS natin dito?
2m is less than or equal to m plus 1 factorial po.
Okay, great. Thank you, Dad. That's correct. So para makuha yung WTS, so kung ano yung gusto nating ipakita, lahat ng M kay HOI, papalitan lamang natin ng M plus 1. So kung gagawin ko yon, okay, 2 to the, si M, papalitan ko ng M plus 1 minus 1 less than or equal kay M, papalitan ko lang ng M plus 1. So si M plus 1 na yung nasa loob ng factorial. That's how Gad got this expression. 2 to the M plus 1 minus 1. So that's going to be 2 to the M less than or equal kay, instead na si M yung nasa loob, si M plus 1 yung nasa loob ni factorial. Okay? Is that clear how we got the WTS part? Kasi pag nagkamali kayo sa WTS, guguho na yung proof nyo, right? Kasi mamamali yung ipapakita nyo sa induction step. Okay? Now, so ito yung gusto nating ipakita. Oops, sorry. Ito yung assumption natin. Ano kaya yung pwede kong sunod na gawin to make me closer to the hypothesis of induction? Sorry, to make me closer to the WTS. Ano yung pwede kong gawin? So mag-start ako sa equation na to. Okay. Dito ka mag-start. Ano yung pwede kong gawing susunod? Siguro igilid ko na lang tong WTS. Tapos, then, ano yung susunod na mangyayari? Yes, Daniel?
I'm not sure po, pero multiply M plus 1 to both sides.
Okay, kung magmumultiply ako ng M plus 1 both sides, I'm sure kung mag-work siya. Pag nag-multiply ako ng M plus 1 both sides, I'll have 2 to the M minus 1 times M plus 1 less than or equal kay M factorial times M plus 1. Siguro kaya mo ito naisip, Daniel, kasi pag simplify ko yung nasa kanan, magiging M plus 1 factorial, tama? Kasi ito ay product mula kay 1 hanggang kay M. Tapos, i-multiply ko yung product na yun kay M plus 1. So, itong buong ito ay magiging product simula kay 1 hanggang kay M plus 1, which is the very definition of M plus 1 factorial. Ang problema ko lang dito sa suggestion mo ay itong sa kanan. Okay? So, yeah. Paano ko ito masisimplify to become 2 to the M? Gusto ko to maging 2 to the M. Kaya lang nagkaroon ng extra factor which it seems na hindi ko siya kayang i-simplify. Though, I think kaya ko rin baliin itong proof na to pupunta dun sa gusto kong karatingan. Pero medyo komplikado yung reasoning. So you can try it out, Daniel. I think you can derive the WTS from here. But there's an easier way. And I'll prefer the easier way, at least dito sa discussion natin.
Can I explain
okay.
po why I multiplied M plus 1?
Multiply by?
Can I explain po bakit I multiplied M plus 1 both sides? Kung okay lang.
Sorry, hindi ko magets, Daniel.
Can I explain po bakit I multiplied M plus 1 to both sides? Can is it okay, sir?
Oh yeah, sure, go ahead.
Because I was thinking after that step, you can, since we know that M is greater than or equal to 1, we know that 2M minus 1 is less than 2M minus 2 to the power of M minus 1 times 2 is less than 2 to the power of negative 2 to the power of negative M minus 1 times M plus 1. That's my reason.
Okay. Oh yeah. Yun yung sinasabi ko, Daniel, na kaya mong kunin mula dito yung statement. Yeah, that's true. Hindi pala siya ganun kahirap as I thought. Tama ka. Sige, pakita ko yung dalawang posible proofs. Let's first go through Daniel's suggestion. Kaya tama siya. Okay, isang paraan ay multiply both sides by M plus 1. So, but there, we'll get this guy. Tama? So, makukuha natin ay 2 to the M minus 1 times M plus 1 ay less than or equal to pi m plus 1 factorial. I hope it's clear why or how I got m plus 1 factorial out of multiplying these two guys. Balikan lang yung definition ng factorial. Okay? So ito yung meron tayo ngayon. Kaya lang ang gusto nating left-hand side sa inequality ay 2 to the power m. But this is what Daniel is explaining kanina. Note that m is greater than or equal kay 1, right? So yung m plus 1 ay greater than or equal to 2, right? Then m plus 1 is greater than or equal to 2 by adding 1 to both sides. Alright? Dahil totoo ito, ibig sabihin pala si m plus 1 ay less than or equal kay, si m plus 1 ay greater than or equal kay 2. So that means we can replace m plus 1 by 2 and the result is we'll get a smaller number. Alright? So ibig sabihin yung 2 to the m minus 1 times 2 ay mas maliit kesa kay 2 to the m minus 1 times m plus 1. Right? Kasi si m plus 1, siguro pwedeng ganito. Simula ka rito, then you multiply both sides by 2 to the m minus 1. 2 to the m minus 1 is a positive number, right? So if I multiply this inequality or both sides of this inequality by 2 to the m minus 1, the inequality won't change. Pinlip ko lang yung pagkakasulat. We'll have this guy. But the left-hand side is just 2 to the power m. This is less than or equal to 2 to the power m minus 1 times m plus 1. But from above, we already know that 2 to the m minus 1 times m plus 1 is smaller than m plus 1 factorial. So that means 2 to the m being smaller than this guy, and the same guy is smaller than m plus 1 factorial, we can conclude by the transitivity of inequality that 2 to the m ay less than or equal kay m plus 1 factorial. And that will end the proof, right? So, okay then pala yung suggestion ni Daniel. So you can say na therefore, by PMI, 2 to the m minus 1 is less than or equal kay m factorial for all m greater than or equal kay 1. Okay, the alternative proof I'm mentioning earlier, bigay ko lang ng mabilis. Ito yung inisip ko na mas madali. Sana mas madali nga siya. Otherwise, pero anyway, we have a backup. Daniel's suggestion worked perfectly fine. So dun sa kanina, ang assumption natin ay 2 to the m minus 1. Oh, sorry. Sa conclusion, dapat pala n na lang yung ginamit ko. Though it's not a big deal. Semantics lang naman. Pagtan ko lang siya ng n. Pero ito yung alternative proof ng nung induction step. So ang HOI natin 2 to the m minus 1 is less than or equal to m factorial. I can multiply both sides by 2. Okay. M factorial times 2. And then this guy will give us 2 to the m less than or equal kay m factorial times 2. Kaya lang, alam nga natin na si m ay greater than or equal kay 1. So that means m plus 1 is greater than or equal to 2. So that means I can replace 2 by a larger number, namely m plus 1, and the resulting number will be larger than the two previous numbers. Right? So m factorial, pwede ko siyang palitan, pero yung 2, pwede kong palitan ng m plus 1. And I know that m plus 1 is larger than 2. So therefore, I'll get a larger number. And this guy simplifies to m plus 1 quantity factorial. And so therefore, we have shown that 2 to the m by simplification is less than or equal to m plus 1 factorial, which is the same conclusion that we have gotten following Daniel's suggestion. So discardin nyo na kung paano nyo mapapalabas yung WTS part. Pero ang general idea is gagamitin nyo yung assumption para yung HOI para mapakita yung WTS. Okay? Now, I think that this is a good time to stop. Sorry, medyo overtime na uli ako ng 5 minutes. But next time, we'll continue talking about some more examples. We will skip example number 3. Hindi ko siya napansin nung kinopy-paste ko siya na tungkol pala siya sa set. So hindi pa natin na-discuss ano yung power set ng isang set. So let's forget about example 3 for now. Let's go back to it when we go to set theory. We'll just answer some exercises after. Okay? Pipili na lang tayo ng mga sasagutan dito. So yeah, if you have time before our next meeting on Thursday, pwede niyong i-scheme itong mga exercises. Ano sa tingin niyo yung yung magandang sagutan? Okay? Ano yung pwede nating sagutan sa lecture? Right? Gad, you have a question?
So, pwede pong pababa. Screenshot ko lang po yung... Yan.
Dito ba? Okay.
Ayan na po. Thank you po.
Or gusto niyo ba yung buo?
Ayan, sige po.
Okay.
Thank you
Okay,
po, sir.
zoom na lang. Hopefully mataas ang resolution. Yes, Mary Rose, you have a question?
Po, wala po, sir.
Okay, hanapindot lang. Okay, so anybody else who have a question? So kung wala naman, so okay, let's see. All right, pahabol si Charles. Yes, Charles?
Sir, pahabol lang po regarding the problem set po.
Uh-huh.
Sir, do we have to parang furtherly discuss po yung proof with even and odd integers po?
Some part, problem, 1 point.
Sa 1.2 po. So,
One-
magdedwell din po kami dun sa pag-prove po ng odd integers.
Sorry, hindi ko tanda yung question. So kailangan ko siya, okay. So dun sa problem 1, prove that n minus 5 is odd if and only if n squared minus 1 is odd. So ano yung, ito ba yan, Charles?
Yes po, sir.
So, hindi nyo na kailangang hatiin yung statement sa n being odd and even. So, or pwede naman, pero ang i-assume nyo na ay ang assumption nyo ay si n minus 5 is odd. So kung si n minus 5 ay odd, pwede nyo sabihan kagad na, oh, definitely si n dapat ay odd. Tama ba? Kasi ang n minus 5 is odd. So pag nag-subtract ka ng dalawang odd, tama ba? Pag nag-subtract ka ng dalawang odd, anong sagot? Even. Isip ko kung posible na si n ay odd and even. Kung si n minus 5 ay odd, so ibig sabihin, meron kang n minus 5 ay equal kay 2k plus 1. Mag-subtract ako ng 5 from both sides, I'll get 2k minus 4. Plus 6. Plus 5 plus 6. So even. So kung ang assumption mo si n minus 5 ay odd, sure ka ngayon na si n ay even. So hindi mo na kailangan i-prove yung forward problem, yung forward implication kapag ka si n ay odd. Kasi sure tayo na kapag ka si n minus 5 ay odd, si n surely ay magiging even. So hindi mo na kailangan i-consider yung si n ay odd. Tapos sa n squared minus 1 ay odd, pag pakabila naman, if and only if to kasi, kapag si n squared minus 1 ay odd, 2k plus 1, so si n squared dapat ay even. So, pero alam natin kapag si n squared ay even, nagpo-follow na si n ay odd. So, hindi mo na siya kailangang hatiin from the get-go na si n ay odd o kaya si n ay even. Kasi bawat isang proposition dito sa biconditional ay ini-imply niya na si n ay even. If I'm not mistaken. So, yun. Did I answer your question, Charles? O mas nakagulo ba?
Yes po, sir. Mas clear na po. Thank you po, sir. Thank you.
Okay, you're welcome. Any other questions? So kung wala na, yung mga nag-recite, pa-comment ulit. Ako na yung bahala kay Dad. Pa-comment na lang na nag-recite kayo verbally. Then, so that's it. Thank you for coming today. Enjoy the rest of the day. Tapos kita-kita tayo ulit sa Thursday para i-continue tong PMI. Bye everyone. Good luck sa prop set. Huwag kalimutan magpasa tomorrow.